Okay, we are doing the law of cosines today. We just talked about the law of sines. All right, the law of cosines is best seen with the pattern. Okay, so basically I'm going to put up here a triangle, and I'm going to label our points. And I'm going to write the law of cosines 3 times. And I want you to see the pattern. Now this is not a right triangle, even if it may kind of look like one right there. That's not intentional. So here's C, B, A, little. Okay, so once again, the opposite side, the little thing there. Okay, let's say that for whatever reason, I am interested in this side right here that I put a star next to. Okay? So, here's the law of cosines. A squared is going to equal B squared plus C squared minus 2BC cosine of A. Now, your initial thought here is going to be, gosh, that's pretty complicated. But notice a few patterns. Cosine A squared. Okay, so whatever side I'm interested in or angle I'm interested, they are on opposite sides. Notice the other two things. Okay, the sides that I'm not interested in, the B and C, are B squared, C squared. Okay, and then minus 2BC.
Is it always minus 2BC? Or is it just minus 2 and then whatever?
I'm going to show you it again. Okay, maybe I'm not interested in side A. Maybe I'm interested in side B. All right, well that's going to be B squared equals A squared plus C squared minus 2AC cosine B. Notice again, the side I'm interested in, B squared, and the angle B, and then the other two sides, A squared, C squared, AC. So it is indeed a pattern here. So hopefully, after having seen the pattern twice, you can figure out what the third one would be. Maybe I'm interested in C. So that's going to be C squared, fill it in.
C squared equals
plus C squared
plus B squared
plus C squared
minus 2AB
cosine C.
cosine C.
Yes. So C squared is A squared plus B squared minus 2AB cosine C. Now, I don't want you to fumble around with 3 versions of the same formula. We're going to remember this version, okay? What really matters is that you correctly identify the side that you're interested in, or the angle that you're interested in. Okay, so you really just need to write down this first one, and now we're going to do a few examples where I put in the numbers, and we figure out which one we should use. Okay, so let's put in a few numbers and see which one we would use. Okay, so notice that the law of cosines is going to basically work when I have a side, angle, side set up. See, I have a side, an angle, and the side. So I have a side, angle, side set up. All right, well, do you see that the side I'm interested in is right here?
Yes.
Okay, so that's going to be x squared equals 10 squared plus 22 squared. So the other two sides that I'm not interested in minus double those two sides.
Double.
2, because 2.
Oh,
Because minus 2
Yes,
BC. So double those two sides times the cosine of the angle. Now, actually, remarkably, despite how complicated this formula is, most students are actually able to remember the setup correctly. It's the order of operations that inevitably gets everyone. Okay? Follow the order of operations. Exponents first. So 100, and then what's 22 squared?
Ooh, that's big.
44.
480.
What is it?
484.
And then I'm going to go ahead and do all of this piece together. When I do this together, it's the minus that ends up getting us. So I'm going to type in my calculator, -2 times 10 times 22 times cosine 44. I'm going to take that negative with the 2. So what do I get when I type that out in?
Negative
Negative 440.
No, and you gotta do cosine.
negative
44.
316.5. Is that all you want?
0.51 if you want another
Yeah.
one.
Okay, sure. Now we'll go ahead and combine all those. So now it's just add and then subtract that thing. After I add and subtract that thing, what do I get?
So you want that x squared equals 100 plus 484.
267.49 or 0.5.
260 what?
7.5.
Oh, okay. I see.
Okay. And then, how do I undo a square?
Square root it.
So I square root it.
The square root of 267.5 is 16.
0.4.
Yeah.
Sounds good. That's correct. Okay?
Woo!
Fun.
What's that?
So the next two, we're just going to set up and we aren't going to bother solving them. Okay? We're just get the setup, so we're practicing that. Okay? So, okay. Set up the first one. Jacob.
So we're finding x.
Yep.
So would it be 12 squared equals 7 squared plus 8 squared negative 2 times 7 times 8 cosine of x?
Yep. That's correct. We won't bother solving that. We will do a practice of that in a minute. But that's the correct setup. Now, I'm interested in this side, even though I know it because it's opposite this angle that I am interested in. So those form the two opposite ends of my law of cosines. All right, let's set up this one. Emma, go ahead and set up this one.
Okay. So you start out with x squared equals 10 squared plus 15 squared minus 2 times 15 times 10 cosine 50.
Yep. Okay, so those are the setups. All right, so now we've set them both up. Now that we've set them up, now we'll go back. Let's solve them. So, yes.
Why can't we just use the thing we learned yesterday?
Okay, law of sines. In order for law of sines to work, I need to have an angle in its opposite. So here's an angle in its opposite. What's going to go with the 10 and what's going to go with the 15?
Use our mathematical skills.
Yeah, why?
You can't. Okay?
One.
The reason you can't is you, in order to find one of those angles using 180, I need to know one of the other angles.
Oh,
Okay, so the law of sines will not work.
No, we
Okay.
wouldn't use system number
Sine, cosine,
16.
tangent, but it's not, right?
You set it up into two triangles. Two right triangles.
Okay, I have no idea what you guys are talking about, but I've just answered the question why the law of sines will not work. So we're going to go back up here, and now we're going to go ahead and simplify this. So we're going to follow the order of operations. What should I do first?
Exponents.
Okay, so we get 144 equals 49 plus 64 minus, now 2 times 7 times 6. Now, when I say 2, I mean negative 2. So,
Negative 112.
okay, cosine of x. Okay, it's not that bad. Follow the order of operations. Now I need to get this alone.
Wait, can
So would we inverse cosine?
No, hold up. follow the order of operations. I need to get this alone. So this is like our x. This is our thing. So in order to get this alone, what should I do next?
Divide.
No.
So just add 49.
Subtract 49.
Can you go ahead and just add those two? in the
Yeah.
Yes, I could do that. Okay. So if we want to do that next, fine. We'll do that next. So what's 49 plus 64?
It is 113.
Now, I'm going to give you a huge warning here and an explanation of why I was subtracting the 49. Inevitably, here's where some students put on their helmets and they break the order of operations. They end up combining all three of these. I cannot do that, okay? I cannot combine all three of those because they are not all three like terms. This thing is its own little thing.
I did
Okay?
that and I got
So you cannot do this 113 minus the 112. For the same reason, if I had 44 equals 13 minus 12x, could I combine those?
No.
No, they are not like terms, nor can I combine those up there, but inevitably someone will end up doing that. Okay, which is why I was doing it in pieces to avoid that problem all to begin with. So now what do I do?
Subtract the 113.
Subtract 113.
from 144.
31.
And I copy down, don't lose that sign of the negative 112.
Cosine X.
Cosine x. Now what do I do?
Would you divide by negative 112 cosine?
No, I can't, I'm not going to divide by cosine. I'm pretend. What would I do? You got to come back. When you're doing trigonometry, come back. What would I do if it were just a regular thing? What would I do here?
You would subtract 10.
I subtract 10. Okay, I
So
subtract
add
10.
112.
I would subtract 10. Now what would I do?
Divide by 2.
Divide by 2.
31.
So go back.
No,
I
divide by
treat
112.
this, if you would, please stop talking over me. What would I do to get this alone? I treat that as this one thing. What would I do to get that alone?
Divide by 12.
Divide by negative 112. Okay, so what's 31 divided by negative 112? I need to keep at least 3 decimal places.
Negative 0.277.
Okay, make sure you round correctly. Now, whenever I'm looking for an angle, what do I do?
Inverse.
Inverse. So I'm going to inverse cosine. What's the inverse cosine of this?
106.1.
I'll trust that we have
C.
correctly used our calculator. All right, back here. This next one, we'll go ahead and solve that. Follow the order of operations. I'm going to do 10 squared is 100. 15 squared is what?
225.
And then I do negative 2 times 10 times 15 times cosine of 50. What do I get? So I put in my calculator negative 2 times 10 times 15 times cosine of 60.
Negative 192.84.
0.836.
Okay.
Okay.
Now I combine those, so x squared equals, when I combine all those, what do I get?
You get 322. Oh, and then you guys subtract 192.
129.16.
Sure.
Okay? And then what do I do?
Then you
root it.
square root, yeah.
Square root it. So what's the square root of that?
11.4.
Oh, sweet mother, you guys got calculators. This is what messes you up.
Okay, never
There's
mind,
no
add and
reason
subtract.
that adding and subtracting that you should get that wrong in our calculator. So when we add and subtract this, let's try again. What do we get?
It's the same thing.
He's right, yeah.
192.
Okay, now we take the square root, and what do we get?
11.36.
Where'd your cosine go?
We did
we
it
ate
up
it.
here. You put this in your calculator.
We didn't do it earlier because it was an X.
Yeah, can't do
Oh, okay.
cosine X.
Okay, we couldn't do it because, yeah, there was a cosine x. All right. We'll do 2 more.
What happened to our picture?
Oh yeah, I have it.
When it wasn't, it's not mine, it's Kindle. And she's graciously let me use it.
Okay. Someone set it up. Kindle.
so x squared
Yes?
equals 100 squared.
Nope. 100's not a side. Coleman.
15 squared plus 9 squared minus 2 times 15 times 9 times cosine. Yeah, cosine of 100.
Yes. Okay, so notice every time we log cosines, either my x is at the beginning or it's at the very end. It's never any of these middle things. Okay? So, simplifying, 15 squared is 225 and 9 squared is 81. Now I put all of this in my calculator, including the negatives. So negative 2 times 15 times 9 times cosine of 100. What do I get?
46.89.
8.
So notice, it's a plus now, isn't it? Why? Put in cosine of 100 in your calculator. Just type in cosine of 100. What do you get?
Negative.
So you get a negative thing, right? So you have a negative 2 times a negative, which switches it to positive. Inevitably, someone just copies down the negative all the time. That's why I'm telling you, take that negative 2, and then you don't have to worry about it. If it comes out negative, write a negative. If it comes out positive, write a positive. All right, so now we combine all of those. Yeah, I just dropped my decimal points. You don't do that. I'm just saving us a little bit of time right here. So go ahead and combine all those, and what do we get?
352.
352. I'll trust that we know how to add on our calculator. Now we square root, and what do we get to the nearest 10?
18.8.
18.8. Okay? Any questions?
No.
All right. One more where we'll actually do it, and then we're going to practice deciding if it's law of sines or law of cosines. Okay. Set it up. Daniel.
Okay, we're going to go 7 squared equals 4 squared plus 6 squared negative 2 times 4 times 6 cosine x.
Yes. Now this time I'm going to isolate this cosine x. So I treat it like it's just an x for now. So I go through and I simplify, following the order of operations. Okay, next step,
16 plus 36.
which is,
52.
do not subtract 48 from the 52.
Shoot down.
Okay, now what do we do? Someone else.
Subtract the 52.
And I get negative 3. That this is negative is going to be important, alright? Next step.
Divide by negative 48.
And what do we get? Keep 3 decimal places.
0.0633.
I mean, you can even keep 4 if you want. Alright, and then what do we do in order to get the angle?
Inverse cosine.
And what do we get?
86.2.
Huh?
86.4.
Yes.
So it's almost a right triangle.
But
Close,
not.
but no cigar.
That don't look like no right triangle.
And it's not ever going, when I do it, it's never going to be drawn to scale. So I
Yeah.
just make up the numbers. Okay. Now what we're going to do is we're going to practice. We aren't going to actually solve any of these. We're just going to practice identifying whether we would use law of sines or law of cosines. So in your notes, you're going to write law of sines or law of cosines for each of these triangles. So all I'm going to do, I'm actually not even going to give you any numbers. I'm just going to mark what information I'm given and what I am going to want to find. So we have 4 triangles here, and some of them will be law of sines, and some of them will be law of cosines. So marked in red will be information I'm given or something that I'm solving for. Okay, so I'm going to solve for this, and I'm going to say that I have this side, I'm going to have this angle, and this side. And in this one, I'm going to want this. I'm going to know this angle, this side, and this side. And in this one, I know this. I want that. And I know this, this, and this. And this one, I want this, and I know this, this, and this. Alright, so which are law of sines, which are law of cosines? Alright, first one. Which do you think? Is that law of sines or law of cosines? Alright, Daniel?
It's a law of sines.
Law of sines. Because I could do this. Remember we were circling the other day. Law of sines. If I have the angle and its opposite, that's law of sines. Alright, the second one, what do you think that is? Caitlin Fan. Law of cosines. Because whenever I have a side angle side setup, whenever I have this deal, that's going to be a law of cosines. Alright? This one.
Cosine.
Law of cosines. Because again, the thing I'm looking for, this, and then I have another side angle side setup. Or you could think of it as a side setup if you wanted. Alright, the last one.
LS.
Yep, law of sines, because I have that thing going on. Okay? Good job. Beautiful.
Are we
Put
gonna
away your notes.
check out how Mark?